Assalamu alaikum. I'm Mohammed Ibrahim Azad, along with my team members Abdul Raffay and Dayyan. Today we will be discussing Oberoi's problem in detail, along with a brief summary of Borges' paper. Let's begin, please. Now, the work by Oberoi addresses the problem of detecting dynamic subgraph isomorphism in dynamic graphs, focusing on a snapshot-based representation. Unlike the previous models that aggregated temporal graphs into a single entity, this approach preserves the chronological order of snapshots, making it much more ideal for analyzing dynamic systems like social network systems and etc. That this algorithm identifies all the induced subgraphs in the target graph that are isomorphic to a given dynamic pattern graph. Second slide, please. Yes. The previous methods for dynamic SI relied on aggregated graph models with time-stamped edges, which often disregard the temporal sequence of events. Oberoi's approach introduced a more snapshot-based model, enabling analysis of both structural and temporal patterns while maintaining the order of snapshots. This makes it different and distinct from algorithms like temporal RI and RI, which prioritized edge making over node mapping and failed to capture the temporal evolution of the graphs effectively. Now over to you, Rafael.
After giving the theory and devising an algorithm, it was also important to support it by some evidence. So Oberoi and team tested it on largest time graph datasets such as college MSG dataset and email EU core temporal dataset, which is actually given here in front of you. In this test, they actually compared it with Mackey's algorithm and temporal RI. And it was shown that it actually had the second best overall runtime performance. Other than that, one distincting feature about it was that it preserves the temporal order, which other algorithm actually fails to address. It means that it compares the snapshots in the specific given timestamps. Now, coming towards the execution of the code, we were handed by the code uploaded by Oberoi on GitHub, which had a launcher.sh file. It's better to explain it through actual execution. So let me just switch to VS. Here we can Here in front of you is actually the implementation of code where we have different target and pattern graphs and the number of solutions of it. To understand it better, we need to actually understand its inputs and outputs. Here, the first input is actually the directory in which target graphs are stored. Target graphs are basically the graph are larger graphs which evolve through different patterns. Here, the number of timestamp targets represents the number of graphs that are included in the input. The second input are the pattern graphs, which are actually smaller subgraphs whose isomorphic occurrences basically are checked on the target graphs. The output given by the code, which is represented by the number of solutions here, is the number of matching isomorphic occurrences of the pattern graph on the target graphs. The next output here is the execution time taken by the code to run, which actually shows the efficiency and the time efficiency of the code given by Oberoi. Now moving towards Dayan.
The Borges paper explores how the teams in sports interact through passing and how these patterns affect performances. It uses a temporal graph model to track passing networks over time and focusing on how varied and flexible strategies can help teams to perform better. Moving to figure 3. Figure 3 shows the entropy values of passing networks, which measure how unpredictable the passes are. Higher entropy means the team uses a more diverse and unpredictable passing pattern, which is linked to a team's better performance. This flexibility allows teams to adjust their strategy based on the game's flow and then take advantage of the opportunities. Now, moving to figure 4. If you look at figure 4, it shows the team signatures, which reflect how teams change their passing structure depending on score and pressure of the game. The teams that adapt well show clear shifts in passing patterns during critical moments. This ability, called detergency, means using different strategies to achieve the same goal, which is vital during high stakes situations.